Welcome. Thank you for joining me for today's webinar, Unlocking Automation at Scale, Inside a Microsoft Fabric Success Story. I'm excited today to share with you a recent project we completed and how Microsoft Fabric and process automation together allowed our client to scale their business. My name is Shean McManus. I'm a field CTO here at Netrix. I represent our data, AI, and modern applications team. And in that role, I help lots of customers come up with solutions in the areas of data, AI, custom application development, and process automation that can help them with their businesses. Today's agenda, we went through introductions already. I'm going to talk a little bit about process automation and AI and what that means. Then we'll go through a real world example here with our client, pharmaceutical return credit processing, a very specific niche case for process automation, but I think we're going to then dig back into it and come up with some ideas on how you can apply those principles to your organization. And then we'll close out by talking about how Netrix can help you get going on that. So we have clients that come to us all the time seeking AI solutions to automate their manual processes. And they're often looking at AI as that magic button, that black box that they can throw at a problem and come up with that solution. However, oftentimes these types of processes are deterministic enough that there are better solutions out there. Automation through defined and repeatable processes can often be a better solution than just trying to use the magic AI as the solution there. So, and the reason for this is that AI-centric solutions can be challenging to maintain and challenging to scale. And furthermore, the token consumptions that are required to be able to use AI for everything, those are things that are driving up the cost of operation pretty quickly these days. So when we can separate out those specific components of a project that need AI from those that just need some level of automation, we can come up with a more thoughtful and scalable process and solution for our clients going forward. So let's talk a little bit about our case here. The pharmaceutical return credit reconciliation process, often referred to as reverse distribution, is the systematic method which pharmacies use in hospitals to return unsaleable or expired products to manufacturers to recoup financial credit. And because these manufacturers have very specific and varied return policies, this process is frequently managed by a specialized third-party set of reverse distributors. The reconciliation process begins with a comprehensive physical inventory where pharmacy staff will be identifying, pulling expired and damaged or even recalled products to be treated as recoverable assets. After these products are batched and shipped with the necessary DEA and regulatory documentation, the manufacturer will verify the contents and issue a credit memo to the primary wholesaler. This credit eventually will flow back into the pharmacy's account, at which point the final reconciliation will happen. And this critical last step involves auditing the actual credit received against the original documentation to identify discrepancies such as manufacturer denials, valuation gaps, and ensure that the pharmacy recovers the maximum possible value for its unsaleable stock. To respect confidentiality, I'll speak to our client as an independent consulting firm rather than naming them directly. And our client can't afford to audit all the returns that come back for their clients, as their business is based on finding those variances between the credits sought and credits granted. So before this process was put together, our client was doing all of this manually, and 85 to 90% of the returns were going unaudited. By applying automation to this manual process, we are allowing our clients to analyze a bigger piece of the pie, so to speak. The purpose of reconciliation is to ensure that every eligible return is matched to the right credit. Variances can be identified early and cash recovered accurately and on time. This starts with the return process. So the pharmacy will return product and record that return with their reverse distributor. Then the manufacturer will issue that credit memo, as we discussed before. So our client collects these credit memos and this return processing data on submitted returns so that they have all of that information in one place. And based on that information and their historical institutional knowledge of the process and of their clients and of specific pharmaceutical products, they are able to prioritize their audits and determine where to look, where they're most likely to find those types of disputes. Then that return data is matched against the actual credits and variances are flagged. Finally, for high variance returns, the additional credits can then be applied after submitting the proper supporting data back to the manufacturers. So this is how our client was doing this before we put together the solution, the old way, so to speak. And you'll see on this particular screenshot on the left, this is that processing data that comes back from that reverse distributor for their clients. A CSV or spreadsheet version of that data, tabular data that includes all of the specific line items for each of their returns, and including all of the quantities, costs, and expected credits that are supposed to come back to them. On the right, you see a copy of the credit memo that would be issued back to their customers. These credit memos can be 10, 20, 30 pages with lines and lines and lines of individual transactions, including reason codes and things like that, that are in a structured format, but not a format that can be easily brought into a data lake. So this manual process involved, through their institutional knowledge, being able to go through line by line on those credit memos and comparing them to the processing data on the left and finding the right match, matching up those lines, and then determining whether or not there are specific variances that require additional credit to be issued. From that source data, they would then manually compare and compile those findings into additional Excel sheets and provide those reports to their client as they work through with the parties involved to achieve those full credits back for their returned products. So the limitations here should be clear. Manual processing means excessive time investigating each claim, and a small percentage of available credits actually get audited and investigated, which leads to a significant uncaptured revenue through investigations that are not conducted. So the big takeaway here is that their growth and scaling are a huge major challenge. So using a Microsoft-centric tech stack, we were able to automate this process. I'll talk a little bit here about the components involved, and then we'll get into some of those details in the upcoming slides here. So on the Azure side, we're utilizing an Azure Data Lake as the raw document storage container. That's the place where we're going to put these CSV files, these PDF files, and be able to process them from there. We're going to utilize Azure Document Intelligence Studio, and this is to create custom OCR models that will be used to extract that structured data from the credit memos. Microsoft Fabric is going to be our data platform. We'll use that both for data storage in the form of Delta tables and for the processing notebooks that we can use to apply all of the requisite business logic. And then finally, we're going to use in Azure an Azure Web Service that contains that variance comparison logic. And we're putting that here, abstracting that into an Azure Web Service so that we can call that both from the Fabric side and then, as you'll see later, from the Power App side. On the Microsoft 365 stack, we're using this more as our front end Power App to be able to surface all of the resulting auditing and return data that we're looking at, and Power Automate to call the web service to apply that variance logic and be able to surface that data back up to the end users. So let's talk a little bit about the data ingestion piece. I'll start first with the processing data. That's really the easy piece. CSV files get dropped into Azure Data Lake storage and then can be picked up by a very simple PySpark notebook that's going to just take those structured columns and rows and convert them into a delta table in Fabric that we can then use later to do the variance checking. That's really the easy piece, very standard stuff there. The credit memos is far and away more interesting because we're able to take these PDFs and through that same process, run them through an OCR model, which I'll talk a little bit about. And that becomes more interesting because those credit memos don't always come in the same format. They're coming from different manufacturers, and each manufacturer has a PDF that looks somewhat different. They all have the same types of information, but under the covers, if you've ever done a deep dive of pulling data out of PDF, there's all kinds of metadata and components that are not visible that complicate this process. So we'll talk a little bit about how that was set up. Document Intelligence Studio comes with dozens of pre-built models, things like US tax forms, invoices, bank statements, marriage certificates, pay stubs, all kinds of stuff like that. And we tried using some of the existing models for invoices and things like that because they have a lot of the same components, but they weren't quite accurate enough for our use case. So then we pivoted to putting together a custom model. And the custom model allows you to take any number of PDF files and be able to look through and point and click at the various pieces of that file and map them to specific fields. And so by going in there and doing this mapping, we can train any number of specific PDF formats. So each of those credit memos that are coming from different manufacturers might look differently. We can go in there and map them and then be able to add that to the model. The result of this is that sometimes you get a new format, a new credit memo, and it's going to come through cleanly. You're going to be able to have all of that data picked up because the model is going to have enough supporting information in it to be able to figure out what we need to pull out. But if the confidence is not high on any of those, then we can go in there and add that piece in there. So what that looks like here is this is the testing screen. You can drop those PDFs into the testing model, and you'll see how it goes through and extracts data, complete with the specific fields and, more importantly, that confidence score on the right-hand side. So that confidence score is what allows us to add some additional business logic around that ingestion process. So we have data that's dropped into that Azure Data Lake storage, and that notebook will run either manually or on a scheduled process that will loop through those documents that are waiting to be processed. The OCR model will be called in code via an endpoint, and then that document will be processed and confidence scores tested. So we set up some level of business logic that determines if a confidence score is below a certain threshold. We can pass that off in the workflow to require some level of human review. And then the human review can occur on that. We can potentially change that data in the form of a CSV file. and then reprocess it through cleanly. So this allows us to have that human feedback if confidence scores are low enough to make sure that we get accurate processing, but it also allows us to understand where those gaps are in the model so that that model can continue to be upgraded and retrained and improved. So the result of the ingestion process is a set of tables in our data lake representing the processing data, the credit memos, and then as we'll see going forward, the actual audit data that is pulled out. And this is the piece here where the magic is actually happening here. A PySpark notebook will be run to capture the core proprietary business logic that our customer is using to both identify, calculate, and compare those variances between those credit memos and that processing data. This is the heart of the process and has this tremendous impact because that auditing in this case can happen quickly. This is the piece that was happening manually before, comparing those PDF files to the spreadsheets. And now, once that data is ingested, we can run this and in minutes have hundreds or thousands of return line items that are analyzed and compared quickly. And those results then are sent to that final audit table that you saw on the previous screen. The results of this credit matching process are compiled in a single audit table that is available for query and analysis through our Power App. So this is that front end that is going to allow our business users to be able to take a look at the data that has been ingested and the data that has been analyzed and compared, and be able to determine, all right, now who do we need to report back to, what information do we need to send back to the manufacturer to be able to complete the credit process. So this dashboard here will allow the clients to drill deeper into the relevant processing data, as I mentioned, and compare those results in a tidy report screen, complete with all of the requisite variance identification. From here, they have the information they need to be able to go back and do this. And this information was compiled in a way that was much more quick, much more quickly than the manual process we described at the top of the webinar. So you might be asking yourself, well, where is the AI here in this process? And AI was used sparingly. As I mentioned before, being able to identify those areas where we can use AI in a small targeted set, but not to run the entire process, is a huge win going forward. In this particular case, the biggest application was parsing out return reason from the credit memos. So if you remember those credit memos, each of those line items had a reason that the manufacturer was given for being able to either grant the credit or not grant the credit. And we need to be able to find a way to compare those reasons that were coming from each of the manufacturers that are in different formats and things like that to the 10 or so reason codes that our client uses as their standard reason codes. So that's the case where we were able to use AI to compare natural language reason codes coming from the credit memos back to the mapping them back to our client's stated list. So that's it. The rest of this was just done using automation and OCR, which is technically machine learning. So the reason why we did this way here is, I think mentioned at the top, AI tokens can be very expensive at scale. If you're throwing all of this data at an AI model and trying to do all of this automated processing, you're going to be paying a lot more going forward for those tokens than you need to. Because in this case, our process was largely deterministic. We know we have this data needs to be extracted, and then it needs to be compared using a very deterministic set of business criteria and business logic. So by being able to put that in code and using our orchestration methods to be able to string together those processes and that workflow in an automated fashion, we're able to put this all together in a way that is scalable and allows our customer to have some level of cost control over their solutions. So consider your process before jumping to AI as the sole solution. So the pharmaceutical return credit reconciliation is obviously a custom workflow that isn't relative to most businesses. But the principles applied to this solution can certainly be applied to a wide variety of manual processes that you're probably experiencing in your business. Automation in this context then is the combination of these different silos of processing into that sequential workflow that can remove time-consuming manual tasks. So in our case, tools like document intelligence were used to ingest those credit memos, but they could be used to ingest all types of unstructured data, any kind of PDF, um, even data that's coming in as images. We can turn that into structured data and actionable data sets. Data platforms such as Microsoft Fabric can also serve not just as a storage solution for structured data, but also serve as the entire engine for processing data flows and executing complex business logic at scale. So we've seen all kinds of customers that are using Microsoft Fabric in different capacities. Many are using it as a means to an end, the end being Power BI dashboards and analytics, but we're also seeing it as that intermediate storage layer that's going to allow the facilitation of business logic. So you could think of if you needed complicated CSV files to be created from a myriad of different data sources. You could bring that data into Fabric, run the processing notebooks at scale, and be able to have that CSV file as your output. That would be one example. Analytics is another example where you see huge benefits for using Fabric as an underlying data platform. And then obviously AI. If you do have the need for using AI, think natural language queries on your data or data agents. That's another place by bringing data into Fabric, you are setting up that foundation to be able to execute those types of workflows on that data going forward. And finally, low-code apps can provide um, a way to data and allowing users to interact with your data for final activities. So Power Apps, Power Automate, even Power BI, those are good front end, low code ways of being able to put together visualizations and interactions with data that tie together the entire process from end to end. Breaking down that larger process into defined and deterministic tasks, and then being able to orchestrate those tasks to match the business process is really that key to being able to achieve ROI in process automation projects. So as you look to apply these principles to your own manual processes, Netrix helps clients like these in this and any in other key areas. And we can discuss your manual processes and help design a solution that unlocks that savings. So beyond just process automation, we do a lot of work in the data platform space. So things like data platform MVPs that involve analytics and reporting dashboards, data strategy projects, even things like enterprise data warehouse assistance or migrations. If you were looking to move your data warehouse from on-prem into the cloud, we can help with that and layer on that Fabric component to that data warehouse so that we can start making use of AI and machine learning. We can do assessments on those two areas as well, understand what is AI, what is machine learning in your particular environment, and where the correct application of those exists in your solutions. We can also do Power BI dashboard design too. So if you have need for help in any of those areas, or even areas beyond just the core data and custom application areas, feel free to reach out to us. If you already have a Netrix account representative, reach out to them to start discussing your next project. If you don't have an account executive, you can get in touch with us or me through our info@netrixglobal.com email address. Once again, my name is Shean McManus, and I thank you for taking time out of your day to watch this webinar. Best of luck to you on your upcoming initiatives, and hope to talk to you all down the road someday. Thanks.